Introduction to Analysis of Variance, or as we say, ANOVA. ANOVA. This video lecture is copywritten by Probe Consulting and C. Harold McManus, PhD, 2007 to 2010. Please don't copy this. Thank you very much. ANOVA, or Analysis of Variance, is used to test hypotheses about the difference between two or more means. The t-test can only be used when you have two means. If there are more than two means, you have to use ANOVA. If you conduct multiple t-tests, you can inflate your risk of a type 1 error. ANOVA is also called the F-test. And it's called the F-test because the inventor of ANOVA was named Sir Ronald Fisher. Fisher, a statistician from Britain who was a contemporary of Carl Pearson, who you know from Pearson Product Moment Correlation fame, or R. ANOVA came about based on farming problems in America. Farming, planting crops, how to best plant crops to get the best growth. That's how ANOVA was developed, or why it was developed, I think would be better to say. Okay, what is our null hypothesis? Well, the null assumes that within group estimates reflects between group estimates. That is to say, the same variation you will find within a group, you will also find between multiple groups. That is your null, and I will expound on that in a second or two. We have two estimates of variance. Two estimates of variance. Let's look at my example here. I'm comparing three universities, and we asked 90 students at random, how many hours do you study each week? We have Howard, we have Shaw, we have Grambling. You see the N, you can see on the screen the N at each school is 30. You see your means, Howard 36.53, Shaw 45.47, Grambling 23.77, and so forth. And you see your SD at the bottom there. Here comes the question. If the null is true, then the same variation I will find between those three schools, I will also find within those three schools. And if so, my F will equal to 1, which means no difference between or within those groups. So we're saying this: if the null is true, then students at Howard and Shaw and Grambling are similar to each other, but also similar across the three schools. Try again, each other. It was easier that time. So they are similar to one another, but also to students at the other schools. If that's true, then my ANOVA is going to be 1. Okay? So we're talking about groups. Is there a typical Howard student who is atypical from Shaw and Grambling? Is there a typical Shaw student who is atypical when compared to Howard and Grambling, and so forth? That is, in fact, our question. Go back to your central limit theorem. Our N must exceed 30 from a normal distribution, and we choose our folks at random. And we covered all of that before, but we have N of 30 and so on and so on and so forth, if you will. ANOVA will test the null hypothesis that the population means are equal. Everyone at Howard is the same as everyone at Shaw is the same as everyone at Grambling. Both between and within, they are the same. That is our assumption. Now, if this null is true, then within and between should be about the same because they both come from the same population, if you will. So why would they not be the same? So we are testing the idea that students who go to these three schools will be different in some way from folk at the other schools. If the null is false, there'll be more difference between these three schools than there is within these three schools. If the null is false, then Howard and Shaw and Grambling are the same within the schools on how much they study, but different when you compare across the three schools. That's within and between variance. Let's break it down. I assume that these groups differ on my DV, which is how much time do you study. I assume that people who go to these schools have something in common with other students at these schools, but that they differ from the other schools, and by being similar, they form a group. Howard group, Shaw group, and Grambling group, who are similar to each other, but different from the other schools. We talked before about typicality and atypicality. It comes into play here again, same as it did with the t-test before. All right, in conclusion, if the null is true, then between and within are the exact same number. They perform the exact same way on the how much time do you study question. However, if they are closer to each other but different from the other group, then we can reject the null because it will not equal to 1. Let's now go to the SPSS.